Today I will talk about some basic functionalities of openViBE. We will play with some existing boxes. I will try to explain what each box means so that you can, understand, the basic ideas of how yeah, openViBE works. So openViBE has two parts. You have an acquisition server and you have a designer. In this acquisition server, it serves to receive data coming from an EEG device. Okay, and in order to do that, you have a lot of drivers here. So what I used in my previous tutorial, it was Embryo Train Smarting. You can use, GTEx, all of these GTEx devices, bring products, and a lot of others. You have OpenBCI here, cool. And yeah, so you just basically you need to know which EEG device you have from which brand, yeah. So you just choose the one that you have. There is also possibility that if your device is not listed here, you might try connecting it with LSL, lab streaming layer, but then you need to convert your, for example, I don't know, Bluetooth, like sometimes it's with the BLE, like Bluetooth low energy uh, uh, communication, and then you basically need to protocol, and then you need to like convert that into LSL and then receive LSL data. So your data through LSL protocol in order to, do whatever you want with the data. Visualize or process and so on. So today we will just play with the generic oscillator. So it's just generating different sinus functions and different frequencies, and basically they're summed up, and maybe there is also some noise added to it. I don't know, maybe not. Um, but yeah, so it's generic generated data, generated oscillator, as the name says itself. You choose here how many channels you want. So by default, at the beginning, you have four. You choose a you can choose a sampling frequency here. So if you're connected with an EEG device, you need to check their sampling frequency so it matches the one that you choose here. So for example, Embrain Train Smarting has an option of 256 and 512. So you choose one of these. You can't choose some other. I mean, you shouldn't choose another sampling rate frequency, and that it will make some errors or do some weird things. Okay, so let's do that. And then preferences. Let's see, preferences. I might have talked about already what is drift correction, what is drift tolerance. So basically, drift tolerance is if I put 200 here, you see it's 200 milliseconds. This means that until 200 milliseconds, it will tolerate, for example, the packets that are late or that are arriving too early. And then if it reaches this full bar, and if it reaches like 200 milliseconds of latency, then it will reset the buffer, basically set it to zero, and it will correct it will perform a drift correction. And what it will do is that it will basically replace the last correct value received. So what it will happen that it will add or duplicate the data that was lost with the last one that it received before. So it doesn't, so it doesn't produce let's say, refreshing of the buffer doesn't produce some, zero values or some holes, let's say, in our signal. So it wants to like, fill these gaps. Okay. Um, yeah, so if you set like 256 sampling frequency, then if it's, late, if it's arriving a little bit later, this value is arriving at, I don't know, something more than 256, then you will see that it's how it's late. And then this buffer is basically filling out, filling. It's with late packets. And what is critical here is that imagine, so you have this motor imagery, or you have a P300 paradigm in BCI, and it's very important that you have the data that is arriving, in the right time. And in this case, you will be receiving, the data like 3 seconds late or something, or well, okay, depending on how much you put the tolerance and how much. So it's very important that you don't, so this tolerance shouldn't be too low either. If it's set to 2, for example, we see to 2, then correct, it would do this drift correction too often. So if it too often corrects this data, you will kind of create like a lot of fake data, because you will like refresh. Okay, yeah, I won't let any late packets to just stack up, but if I refresh it too often, then and replace the data with the ones that arrived before, I will just have too often some false data. Yeah. Okay. And this thing is, for example, 4 values of these 256. So it's 256 divided by 4 times that I will send these 4 values. Okay, so I'll send four of these samples of 256. Okay, I will send this, it's like a buffer. So it's these 4 values. I receive 1, 2, 3, 4 of these values, and then I send them to the designer. Okay, because if I would, but 4 is actually too fast. What we do in EEG, if we have high sampling frequency rates, 32 is also okay, because you don't want to, I mean, your system, it will be overloaded. We don't want I mean, imagine sending 1 by 1 value, so it's not really possible to keep up. Okay, so we're sending it in a buffer. Okay, okay. Then, okay, if you want to start, then you connect and play. Okay, then you're sending these generic, oscillations to your designer. Okay, so let's open a new, oops, no, let's just create a new scenario. What we need if we want to receive the data coming from a server, we need an acquisition client. And this acquisition client, so if your acquisition server is actually in another computer, not on your own, then you will need to put here the IP address of this other computer. So we have the acquisition client. What typically also is useful is this temporal filter. Temporal filter. If we want to filter, for example, if we want to use like beta or alpha waves and so on. So beta will be like around, I don't know, sometimes it's 15 to 30. Sometimes it's like, sorry, sometimes like I'm a little bit sick actually, so uh, difficult to focus. So it's from 15 to 30 beta, or from like, I don't know, 8 to 12. Oh, sorry. You would have your alpha waves. And this is the band pass filter, okay? Band pass, so it's passing these frequencies between 8 and 12. Band stop would mean that you will let all the frequencies below 8 and above 12 to pass. So you will let all the frequencies below 8 and above 12 to pass, but only, you will stop only, oops, band stop. You will stop only these, between 8 and 12. The band stop can be useful if you really want to like just take out, I don't know, like from 40 to 70 or something like that. Meaning that you just want to take out the muscle artifacts. Well, muscle artifacts can be even higher. But like if you want to take out muscle artifacts, or just, the electric current, which depending on the country you're in can be 50 or 60 hertz. So maybe, you just want to stop these and you want to let everything else pass. Okay, so let's just, for example, do, yeah, and high pass would be, passing everything above 70, low pass, passing everything below 40. So, okay, I think that's quite um, trivial, I would say. Okay, and then 1230, let's say we're passing, I don't know, some kind of beta. Temporal filter. What else do we have? What's also useful is, for example, the channel selector. Channel selector. Well, here we have in our acquisition client, we saw that we have like these four channels, right? And we want, for example, just to select the first channel. If we wanted to select like from the first to the third channel, it's the syntax is like this. Or this is action, it says select, but you can also reject from the first to the third. So having only the fourth. So what you will have here, what we will have passing here in this output from the channel selector would be only the fourth channel here. Okay, let's leave, for example, select first. You can also have, then select another one. Let's just copy, paste this. Oops. Did I select this? Copy, Control C, Control V, Control C, Control V. Okay, I copied it now. Then we'll send the signal here, and I'm gonna select, for example, the third channel. I don't know, I'm just improvising a bit here. And then now what I can do, I can, for example, yeah, what's really useful is the signal display. Okay, so let's just see what we're having here. Let's see. Play to see. So we're having these like oscillators, these four, like sinus-like functions. And here we can actually see the left ruler. We can see the values, okay, that we have. So from -2 or -3, -4. Okay, so that's cool. We can check that. We can change some colors. Okay, I never really played with this. I need to admit that, but you could play, tweak stuff, and check how it looks. Okay, so we have this signal display here. What is also really, really useful is matrix display. Basically, with a matrix display, you can really see the chunks that I told you about, like this buffer, these values that are being sent from the server. It's in 32. So we have 32 values that the designer is receiving. Okay, so we're receiving 32 values, and we're receiving 4 channels per 32 values. And each of them is changing in this with the speed of, what did we say? I think it was 256, but then it's 32 values. It's like you're taking 32 values of these 256 and you're sending 32 by 32 by 32 by 32. So it means that the time that you're sending, it's just 256 divided by 32. Okay, so let's do that, yeah, and then you can, when we do this channel selector, okay, let's just rename this, left click, rename box, I don't know, for channels, let's just call it, I don't know. And if we copy paste this, and we can rename this as first channel, and if I connect this here, okay, if I connect and then play, you can see I have one channel. So this one channel is having like these 32 values. Okay. So what I want then, for example, I don't know, maybe I can also, then you can check, you can play with this, you can like be like, oh, okay, I can maybe display this filter, how it looks when I filter this, okay, and then you can say, okay, so I'm gonna let you, do whatever you want with whatever you imagine to do. What else will I tell you? I will talk about DSP. This is a very important thingy. DSP is whatever kind of operations you want to do with your signal, you use DSP. DSP is digital signal processing, I think. Yeah. And so you have this X, so you can do whatever you want. You can do X times 2, you know. You can just do that. You can do a sine X. You can do whatever you like. You can do like logarithm of x, and then you say, okay, I don't want any negative values, and then you're gonna be like, oh, okay, then so starting from 1, and so on and so on. So you can do whatever you like with your signals. And of course, why did I put this like that? I can say, oh, I actually want to, sum these two channels. How do I sum them? Well, I'm going to use this operator, okay? And how I'm going to do that? Well, I need another input. There you go, inputs, new, input signal. You're adding an input signal, and the type is, type is signal. I'm going to use a signal. I'm not going to use a matrix and so on. Okay, and here it is. I have two of them. Let's just connect these two. Okay, that's cool. And so here I want to do, for example, so just in case, I'm not sure if XY works, Z, what is the real nomenclature, the naming, but you have input A, input B, and let's just call it A plus B, for example, or A times B. I don't know. You can do whatever you want. I'm just, giving you some ideas. Then you can display that again, see the matrix. Oh, wow, that's cool how it looks like. My signals are being, summed or subtracted or whatever. Then, what you can do is, for example, you can say, oh, I actually only want one value. I don't like having all of these 32 values at once. It doesn't mean anything to me. Okay, so how to do that? Well, you can actually do something like signal average. But then you're like, okay, let's do that first. Signal average. Signal average. So I actually just want an average out of these 32, right? So if I do a signal average right from here, it will average each channel separately, 32 values per block. Okay, I'm going to do that. And I'm going to do the other one so you can see maybe the difference. So if I do, if I do that, and I'm going to do this, and I'm going to rename this. Why am I renaming it all the time? Because, well, when you click play, you have like a lot of these windows, and so it's useful to rename them so that you know what you're looking at. Average. I'm going to put average, all average, so that you can see what's the difference. And if I put average, I don't know, average here, just the third channel. You're getting my point. I think you're gonna understand it. I'm gonna average only one channel, so it's gonna have these 32. Well, all average. Wait, what is this? Third channel, 3 average. Okay, and so yeah, and then let's click play. So you see, I'm oscillating this, and where is my all average? And you see, so here each channel is being averaged. You're getting, and how often is it being updated? Well, 256 divided by 32, right? So because you're actually averaging your 32 values at once, okay, that you're receiving. But what if you don't want that? What if you want to actually average the whole second? What if I want all of these 256 values that I'm having in a second, that these samples that I'm having in 1 second? What if I want to take all of them and then make an average, and then make even maybe an sliding average, or a moving average? Okay, so if I want to do that, I need a temporal no, time-based epoching, sorry, time-based epoching. I want to do that. So here what it says epoch duration, it's like a buffer, right? So it's basically saying, okay, I'm going to wait 1 second. So I'm going to receive 256 samples. I'm going to wait. And I'm going to, you know, um, well, I'm going to create, it's like I'm going to convert it into 0.5. So basically, if I want to receive only one value per second, I'm going to do this. Or, okay, let me first show you how this looks like, and then I will show you how it looks like when I average it. Okay, let's just do that. Okay, so time-based epoching, blah blah. I'm going to rename it time-based. Oh, yeah. Okay, so it's time-based all. Ooh, it's complete. Yeah, it's just it's gonna. Okay, oops. It's too much. I should not have. I should have foreseen that. It actually happened a bunch of times. Okay, thank God it didn't explode. Or maybe it did. It's not working anymore. Ha ha ha. Oh, duh, no, no, no. Please stop, stop. Uh, did it stop? It did. Okay, it did not explode. Okay, okay, thank God. Okay, I should have seen that. Okay, so what happened here is that it's directly taking, it's trying to, display 256 values at once, and even like for 4 channels. So it's a lot, and thank God it didn't just explode. My computer is still working. So what we want to do is for example, let's not do that for all, okay? Let's not do that. Let's just take, for example, let's just take, I don't know, let's just take channel selector number 2. Okay, I'm gonna take it from, I don't know, what was it? Was it alpha that we used? I don't remember. Okay, channel selector, let me take 2. Okay, it doesn't matter. Maybe it was better that I first select the channel and then do 10. Well, who cares? Okay, it doesn't matter. It's the same. Because here I filtered all of the channels, and so it went filtered all channels, and then I'm selecting the second one. That's okay. And what did I want to do? Yeah, time-based epoching. Time-based epoching. I want to show you. So if I do that, I'm going to have only one channel. That's okay. I'm going to wait for 256. Okay, let's not do that again. What I'm going to do, I'm going to take an average of all of these 256 data, and then I'm going to, display it for you. Okay, time-based. Yeah, I shouldn't have deleted that earlier. Time-based. And so what happens is, for example, here, what we see here is that this will probably fluctuate. The values will fluctuate a lot more. Let's see, time-based. That's right. You see. So not only here the values, okay, we're not far away from 0 because, well, it's a perfect kind of perfect sine wave. So uh, um, if you do an average, well, it would be probably around 0. And here, so or an average of 1 whole second, right? You're taking the whole period and it's around 0. But here we're averaging, a lot more often, okay? So this is fluctuating a lot more. Okay, this is what I wanted to show you. So we're giving one value here every, you know, 256 divided by 32 times. And here we're giving it every half a second. We can also do it, we're taking a whole second that we're averaging, but we're displaying a half a second. See? Let me just, you know, I don't know. I can just disable. You can disable some things so that because it's a little bit annoying seeing it in the background. Um, I don't know. Let's just disable that. Okay. Um, so yeah, I hope you understood what time-based debugging does. So basically, so if I want to get only one value every second, so only one average of these 256 samples, and I want to have it only once per second. So you see, 1, 2, 3, 4. Huh, I'm still, what is this? 4 channels? Why am I displaying that? I have no idea. Why is that? Where is it? Ah, 4 channels. Here you are. Okay, I'm gonna disable you. Oops. No, not you. This guy. Okay, disable. So, what else did I want to show you? Okay, for example, this simple ESP, I can say, okay, well, if this is, I don't know, bigger than 0, if it's, higher than 0, or equals, yeah, let's just, oh, is it? Yeah, I don't know. Well, DSP will, in its output, it will just have a true or false value. Okay, so be careful if you're doing like a simple DSP here, and you want just, for example, positive values of a log, as I mentioned earlier, of a log function. Then you just want to like put +1 inside. You don't wanna say, oh, I want only the positive values of a log function. Well, if you do something like that, with like one of my students did, this doesn't work. This just gives you a true or false value, a 0 or 1 at the input. It won't give you a logarithm. It won't give you a continuous function. It will just give you 0 or 1. So be careful not to do that. Okay. Then what I'm going to show you, I don't know. Yeah, let's display. These display guys like matrix display and signal display. They kind of serve to me like a debugging method, so that you can see what's going on. Um, let's see, simple no, bool. Sorry, bool. Let's see, the true or false thingy. So, oops, what did I do? Yeah, it's greater than and equals than. Um, is it? Yeah. Okay, so my mind just blocked in a second, and that was just weird. Okay, bool, let's see what's going on. So it's giving you 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. But I don't really want that for all of my 32 chunks. It doesn't really make any sense to me. So what I'm gonna do is, okay, I'm gonna do it signal average. Yeah, maybe it's gonna be stupid, but I'm just gonna, okay, I'm just gonna do this, and then I'm gonna do, this, and then I need to make another DSP. This I'm gonna change. Just gonna do A plus B, and then I'm going to average it, and then I'm going to do another DSP and say, okay, if this average is, ugh, wait, inputs, can I take one out? No, I need to get a new one. DSP, simple DSP, okay, average. This is actually what reminds me. So if you want to do, for example, in motor imagery, if you want to do something like power band, like calculate the power of an alpha band, because in motor imagery you use power bands. You calculate the power of the band, alpha and beta. Well, alpha, it's technically it's mu. I mean, it's the same frequency range between 8 and 12, but it appears, it's called mu because it appears, with this phenomena during the motor imagination, and once you release you stop imagining the movement, then there's something called beta rebound. So that's where you're using alpha, mu, and beta. Okay. So this is a way often of, so what you want to do, for example, okay. Um, let's do this example where, let's do it maybe somewhere else. Um, Wait, temporal filter. Okay, temporal filter. I'm selecting one here. Let's do time-based epoching. Okay, I'm taking all. Let's do another DSP. I'm gonna show you how that looks. Okay, something useful, right? Time-based epoching. Then here you're gonna do, if you want to do this power, if you want to calculate the power of alpha, are we doing alpha here? Temporal filter, which one is it? Beta. Okay, we're doing the power of beta, calculating the power of beta. What we do then is we calculate the average of all of these, and we often update it a lot more often. Like, now I'm not sure. More than a, I don't know if it's something like that. I think it's quite often in seconds, like, yeah, maybe something like that. I don't really remember. So we do that quite often, where we like having the sliding window, sliding epoch. And then, yeah, and then when you do this, so you're gonna have like this power, and when you average that afterwards, you want to like normalize it. You want to normalize it, and so to normalize it, you're using the log function, the positive values, right? You don't want to use the negative values of the log function. So this is quite useful, and important for you to know. Well, I mean, this exists in these scenarios, right? Let me see. Is it here? No, here. No, for the classifier, right? So here, that's what they're doing here. They're doing the time-based epoching. Yeah, here it is. So every, I think it's 16 hertz. They're, updating updating this epoch. So they're creating these epochs, and then they're doing like this power. They're multiplying the signal with itself, averaging the data, that is from the whole second, so all 256 samples, and then, it's being normalized with a log, a logarithm, the positive values in a logarithm. Okay, so we're normalizing this data. So this is quite useful. You can learn a few things by playing with DSP and seeing how it looks like and so on. What was that I wanted to do here? I forgot. Sorry, my brain is just like, I'm just tired. Signal average. What did I want to do here? I wanted to, yeah, I wanted to show you the like bool. Yeah, and so here, if, yeah, x is like, uh, 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 you know, equal to 0, greater or equal to 0, then, show me that. Okay, let's do that. Time based. No, this is not what I want to show. Okay, yeah, you see, so here you have like this power value, which again is not really fluctuating too much. Um, mm, mm, mm. What I want, here. So it's 0 or 1, 0 or 1, 0 or 1. See? So if you want to have like this true or false, or like, 0 or 1, all or nothing kind of response, or, want to control something like, between 0 or 1, on or off, this is useful to know. Um, okay, what else can I show you? Yeah, this is very important actually, spatial filter. Spatial filter, but just a normal one, like what we can use is like the bipolar or Laplacian spatial filter. So basically, this is a little bit confusing. If you look at this just means you have four input channels. Okay. Well, it makes sense. You can have four input channels if you do that, right? But if I'm already selecting only one, then I'm only going to have one input channel. So you need to pay attention how many channels you're having in your input. By default here it says four, but you can change that. You can also, send eight or whatever. So here you need to change that. Output. In the output, I can choose, to reduce the number of my channels to, for example, one. And then this little thing, these coefficients won't work in that case because I'm actually linking it to, what my output. What am I sending as an output? And in this case, so you see this, it's like saying, okay, if this was at four, sorry, let's leave it four so you can understand. So this is like, okay, I'm selecting here only the first channel. Then I'm selecting here only I'm basically multiplying it, okay? Selecting the second channel, okay? Multiplying. I'm selecting, oops, the third channel. And then here I'm selecting the fourth channel. I'm multiplying these coefficients, okay? Basically, in my output, I'm just going to have one, channel two, three, four channels. Okay, separately. But what if I just want to have one channel? So in that case, this is unnecessary. And if I do this means that I'm just going to filter out. So this is basically something similar as the channel selector. I'm just selecting the first channel and taking all of the other ones out. But what if I want all of them? What if I do this? Well, and still I leave it as one output, like one channel at the output. This means that I'm going to implicitly sum I'm going to sum all of these four channels into one. So I'm leaving them on, let's say, and I'm taking all of these values and summing them into one. So in the same way, I can actually, subtract first from this. I can subtract from like the second one from the first, and for example, the third as well. I can subtract the third from the. So I mean, you can play with these, or you can just like, okay, I'm not gonna use the last one, or I'm going to subtract this one too, or maybe I can just amplify it. Maybe I can use. Okay, I'm not sure if this works. Huh? Let me see. Spatial filter. Okay, let me see. Let's just, I'm just debug this and see if it's going to give me an error. I have no idea. Rename the box special. Oh, actually, it doesn't give me an error. Interesting. Special. Here it is. Okay, so it is actually calculating something. It might be maybe more interesting to see it as a display. As a display so that we can actually, see. Wait, I'm gonna just take this one out. We don't need it. Spatial signal display. Yeah, see, so we're having only one signal, and it's doing, what did I do? Like the subtraction, the second is subtracted from the first, and so on. I think something like that. Yeah. Oh yeah, okay. And so the fourth one was amplified. So you can actually give like higher coefficients here and like amplify like the intensify your signal. But yeah, you can find out the formula for the Laplacian. The bipolar I think is just one minus the other, something like that. And so yeah, you can do that with your spatial filter here. And then you have something else. I mean, I can just univariate statistics. This is also interesting if you want to like calculate the mean directly, variance, range, median, things like percentiles and so on. So this is also useful if you want. Okay, this is all from me. This is the basics that you need to know about in openViBE. Okay, thank you for watching.